So welcome back. So far we have seen some combinational circuits like decoders, encoders, and also we developed VHDL programs for those combinational circuits. Now in this session I would like to discuss three-state buffers. Three-state buffers. What is meant by three-state? Actually, in digital we have only two states. That is on state equivalent to logic 0, half state equivalent to logic 1. But what about the third state is, that is high impedance state. The third state is the high impedance state. That means output is disconnected from the rest of the circuit. Okay, that state is referred as the third state. Okay, or high impedance state. So here the slide representing four different types of tri-state buffers. The first one is called non-inverting active high enable. That is, the tri-state buffers has, in addition to input and output lines, an enable input also there. Okay, so if you take any tri-state buffer, in addition to input and output lines, it also has an enable input. Okay, so the symbol A represents the non-inverting active high enable tri-state buffer. Okay, non-inverting. If you see the symbol, inverting means at the output you need to have the bubble. Okay, it is a non-inverting symbol, non-inverting active high enable tri-state buffer. Coming to second symbol, it is also non-inverting active low enable tri-state buffer is. Okay, whereas third one is inverting active high enable, inverting with active high enable. Okay, so whereas in the fourth symbol it is also inverting, but the enable is at active low. The enable is at active low. This is the enable input. Okay, you remember or note down. This is the enable input. This is the data input, and this is the output. Primary input, primary output. This is the enable input. Okay, so like the tri-state buffers has three states: logic 1, logic 0, and high impedance states. Okay, so because of high impedance state, the advantage is we can observe at the output of the programmable devices and also in some microprocessors. So what is the purpose is one of the advantages is to reduce the number of output lines. Okay, because of these tri-state devices, you can reduce the number of devices. You can share common bus for transmitting data from many sources to the output. Okay, so like that you can see the advantages of tri-state buffers. Now let us see what are the MSS ICs are available for these tri-state buffers. Okay, so here is one application we are representing. Okay, here there are 8 sources, but sharing one common bus to transmit the data. Okay, so the 8 sources are from the decoder. 74138 is the decoder. Okay, so the decoder outputs acts as a enable inputs for all the tri-state buffers. If you observe, the decoder outputs acts as a enable input for all the buffers, and P, Q, R, S, T, U, V, W are the 8 sources. These 8 sources, but using a single bus, a common bus to transmit the data. Okay, so because of this decoder, you know the decoder functionality based on the input combination, only one of the output line is only one of its output is in active, whereas all others are in inactive. Okay, so that since the output acts as a enable input for the tri-state buffers, out of 8 tri-state buffers, only one tri-state buffer is in active and allows its corresponding input to the output. Okay, so that data only transmitted through this bus to the rest of the units. Okay. Suppose if you apply a 000 at the decoder input, the corresponding y naught only is inactive, whereas other outputs are inactive. Hence, the tri-state device which has p input, that particular tri-state buffer is inactive, whereas all others are the inactive. Hence, the whatever the data on from the p, that is transmitted through this buffer to the rest of the units. Suppose if you apply at the decoder input 111, that is 7. So which output of the decoder will be active? Y7. Y7 will be active. Okay. So whereas other outputs are inactive. Hence, except W tri-state buffer, all other buffers are inactive. So therefore, whatever the data is there on W, that is transmitted through this bus through this bus to the next units. Okay, so like that, 8 sources sharing one bus, that possibility is achieved by these tri-state devices only. Okay, so that is the advantage. Okay, and now here is one MSI IC, that is 74541. What it is? Octal non-inverting tri-state buffer. Okay, already we have seen the tri-state buffer symbols: inverting, non-inverting, with active high enable and active low enable. Okay, now this is a non-inverting buffer. Okay, with active high enable, I think, with the active high enable, right? With the active high enable. And what is octal means? This particular IC has 8 such buffers, 8 such non-inverting tri-state buffers. Okay, so A1, A2, A3, A4, A5, A6, A7, A8 are the 8 inputs to the 8 buffers, and Y1, Y2 up to Y7 are the 8 outputs from those buffers, whereas G1 and G2 acts as a enable inputs. Okay, G1 and G2 both at active low and act as enable inputs. So let us see the internal logic diagram for this 541. So this is the internal diagram for the 541. Okay, so it includes 8 tri-state buffers with the active high enable internally, but externally the enable is active low. Okay, so A1 up to A8 are the inputs to the 8 buffers, and Y1 to Y8 are the outputs from the buffers. Okay, so whenever G1 and G2 both are 0, the output of AND gate become 1. Therefore, all these buffers are in the active mode because their enable is at active high enable. It requires logic 1 value. With G1L, G2L zeros, the AND gate output is 1. Therefore, all the buffers are in active. Hence, the output Y equal to A, because all the buffers transmits the data on A to Y. Okay, that is the functionality of this non-inverting tri-state buffer. Okay, so let us see another IC, that is 74245. This is also octal tri-state, but a transceiver. It acts as a transceiver. Okay, transceiver means it can transmit and also acts as a receiver. It shows both transmitting and receiving actions. That is, it acts as a bidirectional device. That is, whatever the data available at A is transmitted to B, or whatever the data available on B also transmitted to A. Okay, so that direction is controlled with the direct DIR input. The direction, the data transmission into the to right side or left side, that direction decided by the DIR input. Okay, and G is at active low, acts as the enable input. Let us see the functionality and internal diagram. So this is the internal diagram of this transceiver. Okay, transceiver, its size is octal, so it includes 8 buffers, 8 buffers in the input A and 8 buffers at the output B. Okay, and this is the direct DIR input to control in which direction the data will be transmitted, from right side to left side or left side to right side. That is decided by DIR input, whereas the G is the enable input for all these uh, buffers. Okay, suppose assume if the GL is 0, the GL is 0, that means proper input we are applying at GL, the GL is 0, and DIR value is also 0, DIR value also 0, so with these inputs, so here we can observe two AND gates with the bubble inputs like that. The lower AND gate output is 1, whereas upper AND gate output is 0. Okay, with the GL is 0 and the DIR value also 0, the lower bubble AND gate output is 1, whereas upper AND gate output is 0. So since the output of these AND gates acts as an enable input, for all these buffers, and this AND gate output acts as an enable for these buffers. Okay, so therefore if you observe all the lower buffers are in enable mode now. All the lower buffers are enabled now. Hence, the data transmitted from right side to left side, because lower buffers are in enable. For the lower buffers, input is B, output is A. Okay, so A equal to B you can observe here. Suppose if the DIR value is 1, okay, the output of upper AND gate is 1 now, but whereas the output of lower AND gate is 0. Hence, with reference to this AND gate output, all upper buffers are in active, whereas the lower buffers are in inactive. Hence, since for upper buffers A is the input and B is the output, therefore the data transmission you can observe from left hand side to right hand side. Okay, that is, you can see here the Boolean expression as B equal to A. Okay, so if the DIR is 0, A equal to B you can observe. If the DIR is 1, B equal to A you can observe. That is, DIR 0 means the data transmission from right side to left side. If the DIR is 1, the data transmission is from left side to right side. That is the functionality of this 245 IC. Okay, so these are the some of the tri-state devices, their functionalities, and MSI ICs. Right? With reference, you develop VHDL program for these two ICs. Right?